Graph the following functions. F of x is equal to 3 times x minus 1 squared plus 2. So for example A, I've gone ahead and drawn the traditional parabola on our grid. That is not the graph that we're going to ultimately end up with here, but I wanted to show the original parabola to kind of give us a reference point to work from, because I can tell that this function is basically a quadratic function, right? If I were to expand that binomial and then do all the kind of distributing and combining of like terms, I would eventually see that it's just simply a quadratic function, which means it's going to have a graph that is a parabola. The question is only, what will the parabola exactly look like? Where will it be located? Will it open up or down? Will it be skinny or will it be wide? That sort of thing, right? So we're going to tell that by the transformations that occur. So the first thing I want to point out is that because of this change here and this change here, the vertex will not be located where it is in the original graph. We're actually going to therefore move the graph to the right 1 unit because of this minus 1. That's going to move it to the right 1 unit, and then this plus 2 is going to move it up 2 units. So that means we're going to go 1 over and 2 up to start the vertex right here. All right, with that change in mind, then we have to think about the other change, which is that 3. Now normally the function might open up, I don't know, something like, say, this, right? Maybe it's going to be that traditionally. But because of the 3, it's going to open up 3 times as fast. So that means when you plug numbers into the function, it's automatically going to rise 3 times as fast as it used to. So we want to kind of represent that by making it much skinnier, right? So something like this. And again, do we actually want to just kind of make it look skinnier, or do we want to plot some points? We can plot some points, but just to give you an idea, we expect it to open up because the 3 is positive, and we expect it to open up faster than it normally would. So it's going to be kind of skinnier than it used to be. All right, so let's actually plot a couple of points though. We know where the vertex is located, but let's plot a point or two to see what happens. What I'm going to do is pick a point that's to the right and to the left of the vertex. And then you can pick another 2 if you want to do after that. It's up to you really, whatever you want to do is fine. But for example, the vertex seems to be occurring at 1 on the x-axis, so let's pick the point 2 and 0 for x. So I'll do 0 and 2 for x and see what that gives us. What happens if you put 0 into the function? Well, if 0 goes in here, you end up with negative 1 squared, which is 1, and 3 times 1 is 3, plus 2 is 5. So we get 5. Now 2 should give us the same answer, so I'm just going to plug in 5 for that. You can check that on your own. If you put 2 into that, you get 2 minus 1 is 1, 1 squared is 1, 3 times 1 is 3, plus 2 is 5. All right, if you want to get another point from the system, you can go out 1 extra place on each one. So instead of going 0, we'll go negative 1. And then instead of going 2, we'll go out to 3, right? So what happens when you put negative 1 in there? Well, if negative 1 goes in for x, you end up with negative 1 minus 1, which is negative 2. If you square that, you get 4. 3 times 4 is 12, plus 2 is all the way out to 14 on the y-axis. And you get the same when you put 3 in. I guess 3 minus 1 is 2. 2 squared is 4. 3 times 4 is 12, plus 2, of course, gives you the 14 again. So these are our points. If you do 0, 5, it'll be 0, and then 1, 2, 3, 4, 5. That's a point right there. If you do 2, 5, it'll do 1, 2, 1, 2, 3, 4, 5. And then if you go out to 3, 14, 1, 2, 3, and then all the way up 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you're way over here. And then on the other side, you're basically the same about there. And so you end up with, again, as we mentioned before, this kind of skinny parabola that's opening up with its vertex at 1, 2. So important to kind of notate that the vertex is 1, 2 for that function. And that's it. That's how you'd graph the function. If you want to add some detail, you can add the points we added. Or you could have just sufficed with the original sketch we did, which was pretty good. Let's look at the next function. Next function should look like this half parabola on its side. Of course, we know that the function has been transformed. It's not going to look exactly like that. But let's just think about what transformations have been made here. First thing is that they did this negative x inside. Remember, that's a reflection across the y-axis. That means the curve will basically be as if we folded it over on the y-axis, and it'll actually look like that, right? So basically we're expecting it to do that because of the negative. And then because of this minus 3 that's slapped at the end of the function, it means the function will move down 3 units, meaning that its starting point will no longer be at the origin, but rather it's going to be down here 3 units. So the graph will essentially look something like this. And that's it. That could basically be your graph. That would be suffice, to do a rough sketch. But if you wanted to get more detail, again, you could actually do what? Plot some points. So we know the starting point of the function is going to be down here at the value 0 and negative 3. Again, we could check that because if you plug 0 in, you get the square root of -0, which is the square root of 0, and you end up with -3, so that point does exist on the graph. But if we want to plot some more points, let's just create a little table, and we'll plug in maybe 1 or 2 points. All right, so let's see what happens if we plug in -1, see what we get with that, and then we're going to put in, say, -4. Now, the reason why I'm choosing -4 is because, of course, we want to make sure that it's something I can take the square root of easily just to make our arithmetic symbol. The other thing, of course, is we have to put a negative in because you notice that if you were to put a positive, you end up with, something like -1 under the square root. That would not be acceptable. So if I put in +1, I can't do that, right? We also know all the points are going to be on this side of the curve. We just showed where the graph will end up. But even if we didn't know that, you know that you can't put a negative number under the radical. We're putting negative numbers inside the radical here because there's already another negative sign there. The two negatives would cancel each other out. All right, so let's see what happens. We put -1 in there, we end up with what? -1, so it'll be the square root of just 1 minus 3. Square root of 1 minus 3 is 1 minus 3 then, and that's -2 as our final answer for that one. If I put in 4, or -4 I should say, it'll be -4 under the radical, which is going to end up giving you just 4 under the radical, minus 3. The square root of 4, of course, is 2, so 2 minus 3 is -1. And those are the points we get. So let's do that. So if I do -1 on the x-axis, I have -2 on the y. So that's maybe the point right around here. And then if I do -4 and then -1, I'll have 1, 2, 3, 4, and -1 is right here. And so if we plot that, it looks like that. And of course, it gradually goes that way. Not the prettiest drawing I've ever done, but you have the general idea, and it looks like what we were showing before. You can plot more points if you want to. For example, you could see where the x-intercept occurs. That would be something to do. If you want to see where the x-intercept occurs, remember you set y equal to 0, and then you would just see what happens there. So if you do that, you're going to end up with what? 0 is equal to the square root of -x minus 3. So you'd add 3 to both sides, getting 3 is equal to the square root of -x. Then you'd square both sides, and that would lead to the idea that 9 is equal to -x. And so basically they're saying at -9, or when x is equal to -9, we have our intercept. You can check that. If you plug in -9, you'll get -9, which is +9. The square root of 9 is 3, minus 3 is 0. So way over here at 1, 2, 3, 4, 5, 6, 7, 8, 9. About there is where it crosses the axis. And that's it.